Hello, everyone. Can you hear me?
Yes.
Can some? Yes.
Yes.
I have a new microphone that came yesterday from Amazon. So the previous group says that it is a little better than the previous one. So if you cannot hear me properly, let me know immediately, please. Okay. It is better than computer audio, I hope. So we had this last slide that we studied in previous lecture. And do you have any question related to this? If somebody has question, please unmute your microphone and we can discuss whatever question you might have.
Professor?
Yes, sir.
I think I had a question on, I think, slide 12.
Slide 12. Here we go.
Yeah, I was just wondering, why is it wrong to use left recursion? In the bottom there.
Okay. Here we go. So it says identifier is a single letter. So identifier is letter A. Okay.
Mm-hmm.
But identifier can be also previously defined identifier, which is letter A. And you put in front of it character, which is number 7. So identifier is 7A. Is this correct identifier? It is not, because identifier must start with letter. Do you agree with that? So this is why this definition is wrong, because it gives you the possibility to build your identifier by putting characters in front of previous identifiers. So if you have identifier, for example, ABC, you can put in front of it any character. So it can be X ABC, but it can be also 7 ABC, which is not acceptable because each identifier must start with letter. So yeah, it is single letter, and then after this letter, you can put whatever you want. You can put letter or digit, that's fine. But it is not acceptable to put a digit in front of an identifier. What is here? So you can grow objects either by appending something or putting something in front of them. Okay, so if you have a sequence of digits like 1, 2, 3, that's fine. But you can put 4, for example, at the end. 1, 2, 3, put 4, or put 4 in front of that. 4, 1, 2, 3, 4,123. So it is completely equivalent. Are you going to build that from left to right or from right to left? In that case. But in case of identifier, it is not. So in some cases, you have that left and right recursion are perfectly equivalent. In some cases, they are not.
All right. Thank
you.
Yeah.
Thank you. How about this example? Once again today, but if there is something that we could discuss here, so these are all possible type of numbers that you have in Pascal. In Pascal, that's crazy rule that you cannot have a dot that does not have some digits left and right. So left of dot and right of dot, you have to have some digits. So we'll return to that a little later. And then now we have to solve another problem. This is also problem similar to those that come to exam. So it says, write BNF notation to define syntax of FORTRAN data specification for numerical data only. So what we have here is first an example. So the syntax should be able to process the following example. So here is an example of data specification, and let me explain the meaning of this statement. The first thing is that the data specification is specifying some data, like this 3.14 that is stored in variable pi. So by giving this data specification, we specify to FORTRAN compiler that there must be a variable called pi, and inside that variable, you have to put the value 3.14. And this 3.14 has to be stored in that variable at compile time. That means at the time when you compile, you are going to have executable program, and you're going to have also inside some variables that include their values. One of these variables will be this pi, and you put inside 3.14. So when your program starts executing, the first statement that you can have inside would be first executable statement, could be write pi, display pi, print pi. So you can be using this pi because it is already instantiated at compile time. And when the program starts, you already have that. So this pi is a variable that is defined and instantiated, and at execution time, you can use it immediately. You can have only one such object, but you can have more of them. So if you put comma and put another one like this that is called array, then array is an object that has multiple values, 1, 2, 3, 4, 5. So this is an array that has 5 numbers, 1, 2, 3, 4, 5 inside. And of course, this is now a vector, something that has multiple components. Or you can have an object called matrix that has inside values 0.123. Now, if you have small number of objects, a small object number of components like 1, 2, 3, 4, 5, you can write them in this way. But if you have thousands of them, then certainly it is inconvenient, and you are not going to do that manually. What can be done is by saying, put inside 100 numbers 0.123. So 100 is a natural number that is multiplying this 1, 2, 3, and the meaning of that is not multiplication. The meaning of this is repeat this value 100 times. Most frequently, people put initial values like zeros in matrix, and then you can say, put 10,000 zeros. So you say here 10,000 times 0. And then the compiler will take reserve 10,000 locations, put 000 inside all 10,000, and when your program starts executing, you already have instantiated matrix with 10,000 zeros. So what I have to do now is to write syntax of all possible data specifications, like this example here. Of course, this is not going to be completely sufficient for what language can have, because of course you can put inside also characters or strings or stuff like that. So I'm not covering that, but I'm just covering this example, and I want to write the syntax in BNF that is covering this kind of constructs. So we have to define an object called data specification. Data specification is this sequence here. Data, pi, comma, array, comma, matrix, comma, whatever you want. How many of them you can have? Any number, it is not limited. Therefore, I have here the data specification must be defined as keyword data that comes at the beginning. FORTRAN is case insensitive, so you can put data in uppercase or data in lowercase. I put here data in uppercase. So this data is representing itself. Now, after that, we have identifier. Identifier is either pi or array or matrix. And after that identifier comes a pair of slashes. And inside this pair of slashes, there is a sequence of values. So you can say I have slash and here slash, and inside this pair of slashes, I have what? A list. Because this 1, 2, 3, 4, 5 is a list. You can also say here, for example, 1 and 3 times 2. So this would be 1, 2, 2, 2, 3, 4, 5. So each of these components in the list can be this product that tells you how many components you have and what is the value of component. Therefore, this is what is list that I have inside pair of braces. List can also be reduced to a single element. If you have a single element, like here, 3.14, there is nothing more than that. So pi is going to be a scalar value that has only a single value inside. Okay, so that's it. The next thing that I have is the possibility to have more than one such object. You can say data pi is 3.14, and then you have nothing after that. Or you can have after this pi, comma, and then after that another object. So to specify this, I have data specification equals data identifier, and then you have list inside pair of slashes, or you have some previously defined data specification, like for example, data pi 3.14, followed by what? By comma. So this is this comma that comes after data specification from here to here is initial data specification. Then I have this comma that is written here. And after that comes another identifier, array, followed by a list inside a pair of slashes. So data specification consists of the keyword data, followed by identifier and list, or data specification followed by identifier list. So this identifier list can repeat any number of times and must be separated by comma from previous part. So this comma here is this comma here. And it shows this sequence, first component, second component, third component, all of them separated by comma. If you have an object that separates objects, this is called separator. And if you have C, Java that use semicolon at the end of each statement, this semicolon is called terminator. Terminator comes at the end of some construct, and separator comes between two components, so component, comma, component. There are languages that use space as a separator. And then space is the part of language. For example, Lisp or Scheme or Racket, they use space as a part of the language. FORTRAN is omitting all spaces. So for example, I have here comma and one space, and I have this matrix. This space is not part of this syntax. It is simply written here for more readability, so that you see that this is one object and this is another object. But for compiler, this space does not exist. Compiler will go and will eliminate all spaces and make of this one single string of characters, and then will analyze and compile that. So again, we go deductively, top down. First, defining what is data specification. Data identifier list, or data specification followed by identifier and list. So now we have that we finished what is this data specification, but we opened two new problems. we have to say what is identifier, and we have to say what is list. So the next step is define what is identifier. Identifier is pi or array or matrix. So identifier consists of a single letter, which is the beginning, like this A or this P or this M. So letter or an identifier followed by letter or an identifier followed by digit. So I can have array 3, for example, here, or pi 18, pi 18, that will be also a correct identifier. So after each identifier, you can put letter or you can put digit. But if identifier has a single component, this component must be a letter. So you can have here data x 3.14. If it is a single value, or say data p is not without this I, so put p, you are going to have data p 3.14. So identifier is single letter, or previously defined identifier followed by a character, where character can be letter or digit. I didn't want here to introduce character, what we usually do, and I put simply 2 times let in identifier here and here. So identifier is recursively defined as identifier followed by letter and identifier followed by digit. Now we finished identifier, but we still have to say what is a list. So list consists of what? List consists of these components, elements separated by commas. It can be a single element or can be multiple elements separated by commas. Each of these elements inside can have this format, like natural multiplier and the value that repeats. So this is number of repetitions, and this is number, this is the value. So 100 times 1, 2, 3. So it is 1, 2, 3, comma 1, 2, 3, comma 1, 2, 3, 100 times. Therefore, the list consists of such elements and can have only single element, like here in pi, or can be list appended with an element after comma. So list, comma, element. So you have this list 1, 2, 3, 4, put this comma, and put element 5 at the end. So we have 1, 2, 3, 4, and then we append this 5 at the end. So now we define what is the list. This is this list here. What is remaining undefined here? First, we have that inside these lists are elements, and these elements can be either a single number, like for example 3.14, or can be natural number multiplied by any number. So natural number is 100 multiplied by a value that can be either natural number or real number. So this here is now something that is undoubtedly a natural number. So it can be 1, 2, 3, 4, 5, but cannot be minus 17 and cannot be 0. Therefore, I have now to define what is a natural number and what is a number. So these two things. The first thing that I'm going to do is to say what is natural number. If it is a single digit number, it can be 1 or 2 or 3 or 6 or 7 or 8 or 9 and nothing else. If it has more digits, then it can be one of these natural numbers followed by digit. So if natural number is 1, 2, 3, then you can put at the end digit 4 to get 1, 2, 3, 4. So this would be natural number. One thing that is visible here, that this digit, of course, can be 0, because digit is going to be always defined as 0, 1 through 9. So, for example, if I have that natural number is 100, like this here, you are going to have first 1, and then natural number followed by digits 0, and followed another time by digit 0. So it is going to be 1, 0, 0. It is going to be natural number. But compiler will accept also 0, 0, 1, or 0, 0, 100. So these leading zeros are not covered by this definition. So if you have, for example, 007 times 0.123, this is going to be, according to this definition of natural number, be not legal. Therefore, we have to make natural number, if you want to have leading 0, you can have to define this value, and you can say then you can have any 0 in front of natural number. So you can have a previous natural number that is prefixed by 0. You can say or 0 in front of natural numbers, which is not written here. I just take these that don't have leading zeros. Then we have to say, what is a number? Number can be an integer or can be a real number. And the syntax of numbers in FORTRAN is very liberal. So number can have sign followed by unsigned integer. Unsigned integer is just a sequence of digits. So unsigned integer is digit or unsigned integer followed by digit. So it is digit or 2 digits or 3 digits or 4 digits or any number of digits. Therefore, unsigned integer is a sequence of digits. And the number is sign followed by this unsigned integer. So sign can be minus, and you can have that the number is minus 14. So minus 14 here. Or you can have real number. Real number can have sign, plus or minus. And then you can have here unsigned integer followed by dot. So if I say 14 with dot, this is not going to be the value 14, but it is going to be stored using mantissa and exponent as a real number, not just ones and zeros as an integer. You can have also, for example, minus 0.5. Minus 0.5 would be legitimate number. So if you have point and after that unsigned integer, this is a fraction. And you assume that is having 0 in front of this point. So you can say minus 0.123. That would be perfectly okay function. Or finally, you can have unsigned integer dot unsigned integer, like for example 3.14. So 3 is unsigned integer, 14 is unsigned integer, and this dot is this dot here. And this covers everything. This covers this plus or minus 3, or plus or minus 3 with dot, or plus or minus dot 5, or plus or minus 3.5. So all these values are covered by this syntax definition of number. So going top down, of course, we have to say what is unsigned integer, uint, digit, unsigned integer, digit. And then we have to say what is digit. Digit is 0, 1, or 9. These are all terminal symbols. And letter is A or B or C up to Z. You can add here capital letters if you want, capital A or capital B or capital C or capital D. And if you do that, then you will say, okay, you can write upper or lowercase letter. FORTRAN up to 1990 is case insensitive. So you can have upper or lowercase any way you want. Now, if it is case insensitive, uppercase A and lowercase a are interpreted in the same way. But I want you to see that by making syntax definitions, you cannot give any semantic information. You cannot say, if I put here or capital A or capital B, this does not mean that lowercase and uppercase are interpreted in the same way. So you have to have the possibility to understand that they are not the same, not identical or they are identical, and you have to say that in description of semantics of language and not in syntax. Syntax is just taking formal correctness of this. So do you have all components the way this example is showing? Another thing, can we write these definitions top down or bottom up? Yes, we can. So you can start with this sign and say sign is plus or minus or empty. And then I will need letters. Here are letters. I will need digits. Here are digits. I will also need an unsigned integer. Here is unsigned integer. And then at the end, you finish with this data specification. Therefore, from the standpoint of human consumption, you can write that in any direction, top down or bottom up. However, as we said last time, it is much better if you write that top down. If you start with data specification and then you eliminate this data, you don't have to think about that anymore. But you have to create identifier list. Then you say, okay, let me make identifier. Here is identifier. We finish identifier once and forever. Now we have to deal with list. List is here. But list has elements. So now I have to define element. Element has natural. Okay, now I have to define natural. And by doing this kind of definitions, you always terminate with terminal symbols. 0, 1, 2, 3, A, B, C, D, E, F, G, plus, minus, empty, etc. So this is telling you how to create this construct using terminal symbols. And all possible combinations are covered by this example here. Is there any question related to this?
Yes, Professor, I have one question.
Okay.
So in the number, you are saying that we
Could
have...
you, sorry, a little more louder, or let me...
yes, Professor, now.
Put just microphone closer to your mouth. Like
yeah,
this.
now is it okay? Yeah. So
Go ahead.
In the number you are saying we have signed and unsigned integer dot, the second one.
Yes.
Yeah. So over here, when earlier you said that we need to have left like before the dot and after dot, we need to have some digits.
Yeah. For example, you have sign minus, unsigned integer is 7, and here you have dot. So this would be constant minus 7, but with dot, it is not an integer. It is a real number. And that means that if it is a real number, it has to have, let us say, 8 bytes to have sufficient precision. And integer can be only 4 bytes. So by putting this dot, you are also defining the data type of this constant. So this here is a real number. So 0.123. And this 3 here is an integer. So this here has 4 bytes. This here has 8 bytes. Same as this 3.14. So if there is nothing after this dot, like for example, you have an integral value, but stored as a real value, then you put 7 with dot, or you can put 7.0 if you want, will be the same thing.
Okay. And Professor, for the natural number?
I know what you're trying to ask earlier.
Go ahead.
When he was talking earlier about when you put a dot, you must have numbers on both sides. That was for Pascal.
That is the rule that works for programming language Pascal. This here is FORTRAN that has different rules. So this rule here is applied in C, C++, Java, Ruby, FORTRAN. Practically all languages that I know today have this kind of definition of number. So you can have a dot that is written in front of unsigned integer, after unsigned integer, or between two unsigned integers. But Pascal is not permitting you this. So this is illegal in Pascal, and this is illegal in Pascal. You must have integer before and after this dot.
Okay. Yeah.
So this is the rule for Pascal. In Pascal, you cannot write, for example, here, do I have any of them? So, for example, this here, -1, 2, 3, you cannot put dot after this 3. You can put dot 0. But if you have dot, left and right of it must be a digit. And this is the syntax rule of Pascal. There is nothing I can do against that. That's how the syntax is defined. And then whoever writes the compiler has to take these syntax rules and then implement these syntax rules. So if you don't have left and right some digit, it is going to complain. But FORTRAN will not complain. You just put 0.5, that's fine. That is 1/2, 0.5, or 0.5, equally good, or 0.5000, again, the same thing. Okay? Any other question?
Yes, Professor. Can you also explain the natural number concept for leading zeros? I didn't get
Natural number is this line here, what you are asking. Natural number.
Yes, you were saying that they don't have leading zeros.
Yes. In this case, is defined without leading zeros. So, for example, let us say 7. Is 7 a natural number?
Yes.
Yeah. Yes. Yes, it is. If I write 007, would your compiler accept that? Yes. If you have any zeros, that is perfectly okay. However, it is not okay according to my definition here. So my definition is covering only those numbers that don't have leading zeros.
Mm-hmm.
Okay, so I can say that this is the natural number is 1 or 2 or 3, or natural number followed by digit, or 0 in front of natural number. So you can have natural number and have zeros in front of it. Okay?
Yeah.
And that would be a definition that would be complete, but cannot fit in the single line. So I said, don't use these leading zeros. Nobody, are you ever writing a number with leading zeros? Of course not. In practice, if you have to write number 123, you are putting 1, 2, 3, but never putting 0, 0, 1, 2, 3. Okay, this is not what we do. For example, if you take values that you fit in forms, so if they say you say your date of birth, and then if you get a field where you have to write that, then you have two possibilities. One is that they say MM/DD/YYYY. That means they force you to write your month with 2 digits. I was born in April, and I have to write 04. Okay? But if I'm writing a letter to you and say 44, that means 4th April or 33, you will understand that this is 33 is 3rd March. Okay? But if they say MM and DD, then you have to say 03/03. You have to put leading 0. So whenever somebody forces you to have leading 0, I will tell you that, because otherwise you are not going to put it. Why to put something that you don't need? It is waste of time, space, and everything else. So we don't do that. That's why I put this natural that doesn't have leading zeros. Okay?
Yes, Professor. Thank you.
Good. Any other question related to this example? Then we go to study another language called syntax diagrams, which is graphical representation of syntax using directed graphs. So you have graph that has one entry point, one exit point, and then you have a path going from entry point to exit point. For example, like this. You have this Pascal example that we were discussing a minute ago, And then you can have this example solved using syntax diagram. So all correct numbers in Pascal will be possible path from this entry point to this exit point of the graph. So from here to here. So you can go here to plus, and you have digit 3, and you can put here e for exponent plus 7. So 3 times 10 to 7. And this will be one possible path from entry point to exit point. So what is used here is first circle that have inside terminal symbol. Then you have rectangle that has inside an object. And you have these arrows that tells you how to move from input to output. So each path from input to output through any of these possible paths is a correct syntax construct. So if I say number 4, is this correct number? Yes, it is. How to go from here to here through number 4? You go here, go through this arrow, comes here to digit 4. Then after that, bypass this, come here, bypass this, and go out. So this is one path that is going from here through number 4, or through number 7, or to number 33. So 3, 3 twice, and then you go out. So let us study this kind of notation, which is defined using circles that have terminal symbols inside. Now, if we have two circles that are sequentially located, this is the sequence A, B. So you have first here letter A, here you have letter B, and this together gives you sequence AB. And if you want to have exclusive OR, that means if you want to have not A and B, but A or B, then you have to put them into parallel branches, which means that you can go from this point here to this point here, either in this way through A, or there is another option. You go here through B and you go out. Now, the point here is that there is no third option. So this is exclusive OR. You cannot go through both of them at the same time. You have to walk from this point to this point. So you can walk, if you want, through this branch, or you can walk through this branch, but not from through both of them at the same time. So this is exclusive OR. It is either A or B and nothing else. Now, is this clear that this is the sequence and this is OR, which is a parallel construct? Okay? Good. So we now go to see how to make the sign. Sign is defined as plus, or minus, or empty. So what is empty? Empty is this path going through the graph without going through any of these objects like terminal symbols plus or minus. So you can go here with plus in this way, out, or you can go through this graph by going through minus. So it is plus or minus, or empty. You go directly here and don't put anything. So this is obviously a syntax diagram that is showing you sign. If you want to make the digit is 0 or 1 or 2 or 3 or 9. So unfortunately, you have to put all of them in parallel branches. So it is 0 or 1 or 2 or 9. So you have to go through this graph from entry point through one of these circles to come out. So this is digit, and this here is sign. So if you want to make an unsigned integer is a sequence of digits. So you can say unsigned integer is a single digit, or an unsigned integer followed by digits. So You can have digit 7 or an unsigned integer 7 followed by another digit 7. So this is 77. 7, 7, or only 7. Or you can have 3 times 7. So unsigned integer will be 77 followed by another 7. So it is 777. So it is a sequence of integers of any number of them. Here, unsigned integer is defined using previously defined unsigned integer, which is called recursion. So this recursive definition yields in syntax diagrams a feedback loop. So you can go through this digit any number of times. So if unsigned integer is number 7, you go here and say, from these entry points, I go through 7 and go out. So this is 7. But if I want to have 77, I go through digit 7, go back, put another 7, and go out. So practically, this feedback loop tells you that you can loop through this graph any number of times. This is, of course, going same as recursive definition. Creates the sequence that can have infinite size. Well, we know that everything in computers is finite, so infinite size is not going to be used, but you're going to have something that has a finite number of components. Is this clear? Anything that I can add to this? Any question? So what we have seen here is that recursion translates into feedback loop inside syntax diagrams. If you have to define an integer, you can say, aha, I need an unsigned integer and sign in front of that. So you can say integer is sign followed by an unsigned integer. An unsigned integer is this graph here. So you can put this unsigned integer inside this, and that will be perfectly okay. So you can put here plus or minus or empty, and here 0, 1 through 9, and have only terminal symbols. Or you can define unsigned integer because maybe you are going to use it multiple times and you need to have several of them. So you can do it that way. And here we compose integer from previously defined objects, which is perfectly legitimate and okay. Now, if you want to define an identifier must start with letter. So identifier is letter, or previously defined identifier followed by character, where character is digit or letter. So I can say, okay, I have that identifier is a single letter, or letter followed by any number of letters. So you go here, letter, letter, for example, A, B. A, go here, B, go here, and go out. So identifier A, B would be this path from entry point to exit point. A, B, C would be A, and then here B, and then here again C, and then out. A13 would be A, and then here 1, and then here 3, and then go out, and you have that A13 is also correct identifier. So you can write this also as identifier is letter, or identifier followed by letter, or identifier followed by digit. I found that this vertical line seems to be missing in the reader. I forgot to put it. I put it a minute ago. So please fix that, put that vertical line in your reader, because if you are on this slide 22, it is missing. It is simply forgotten. Now, I can write identifier as letter followed by character, which is letter or digit that can have, for example, A, B, 3, C, out. A, B, 3, C is correct identifier. But if you have to go here to letter, you can also simplify that and put this feedback loop going here. So these are two graphs are completely identical. So you have here a letter, or you go back to letter, or you put some digits and letters and you combine them and go out. But the first one must be letter. You cannot go here without going through these letters. So this is mandatory. First must be letter. And after that, you can put either digits or you can put letters. Now, a list. What is a list? List is a sequence of objects separated by separator. So you have object, comma, object, comma, object, comma, object. Objects are identified using identifier. So list can be a single identifier, or can be list followed by comma and identifier. So you have A, comma, B, comma, C, for example. That is a list ABC. To make a syntax diagram, it is very simple. You say list is an identifier, and if you have only one, you go out immediately. If you have two of them, then you have identifier, comma, identifier, and go out. If you have two identifiers, A, comma, B, comma, C, go out, we have three of them, okay, and two separators in between. So comma is a separator, and it is written in the feedback loop between two identifiers. So initial identifier and next identifier. So this is identifier and this here is next identifier. Between them, there is a separator, which is this comma. So when you travel from entry point to exit point, you go through this identifier, comma, identifier, comma, identifier. Pay attention that this comma is not a terminator. It is not written here where the terminator should come, because the terminator should be after identifier. If you put this comma or semicolon here, then you have statement, semicolon, statement, semicolon, but then there is nothing in feedback loop. So if you have a list, the separator is in feedback loop. If you have a terminator, terminator is always in feed forward loop, so it would be here. Now we come to our old friend, this example here, and we have to now make the syntax of numbers in Pascal using syntax diagram. Now it is much easier than before, because you see that initially you have plus or minus or empty. So here we go. We have plus or minus or empty. This is a sign. After that, must be at least one digit or more than one digit. So 3 digits, 1, 2, 3 is 1, 2, 3. We come here, and we are here at the end of this 1, 2, 3. So what can come after that? Can come dot followed by some digits. For example, here is dot followed by 4, 5. So dot 4, 5, and you go out. Now this part that is with dot, which makes this a real number, can be bypassed. Therefore, you can have 1, 2, 3 without any fraction that comes after. So this here is integer part, this is fraction, this is exponential part. This fraction here can be omitted, therefore I have this bypass, I can skip that. Then, some numbers don't have exponential part, therefore I can skip exponential part if I want, and I have this bypass number 2 here. Or I can put exponential part if I want, like for example E15. So to have this E15, you have here E, go here to 1, go here to 5, and go out. So this is E15. Or you can have E minus 7, so E minus 7 out. Or E plus 12, so E plus 1, 2 out. Okay, so you have 1, 2, 2 loops here, 1 and 2 and out. So as you see, this graphical notation is 100% equivalent to this here, to this BNF. So now the question is for you, what do you like more? Do you like more this analytic notation or this graphical notation? Some people say this is simpler because I can visually see, and humans have rather good possibility to visualize things. So when you see this picture, it tells you exactly what can be done and what cannot be done. You see here sequence of digits, sequence of digits, sequence of digits. Nice. You have here sign. You have here E, and you have here the possibility to omit things. So after you look this 1 minute, you will understand what is the syntax, okay? Most likely reading this definition here will take more than 1 minute, I would say. They are equivalent, they are similar, but these are completely different languages to do the same thing. Okay, so I'm not claiming that this is better always and for everybody, but in my opinion, this is a little easier than BNF. Here is example number 2. We have this data specification, and data specification has these objects that in this example consist only of positive or negative values, no multiplication inside. So I have a variable name, and then after that I have the value or number of values separated by commas. So how to make the syntax diagram of data specification? How to do that? Well, to do that, we can first put a single diagram here, or you can put all components separately. So here is the single diagram. You have ID, identifier, which is letter, or letter, or letter, digit, letter, etc. So this is identifier. Then we need an integer. Integer can be positive or negative, sequence of digits. Digit, any number of them, you go out. Now I have ID and integer. I'm going to use here ID, I'm going to use here integer. And then say, the syntax of data specification is this data, now written in lowercase, any case is good, inside an oval or circle. So data followed by this list. So object, comma, object, comma, object, comma, object, go out. So here we have 2 objects, this one and this one. You can have any number of them. Each object consists of identifier, and then you have here slash, and inside is list of integer, integer, comma, integer, comma, integer, slash. So between these 2 slashes, you have sequence of integers. Each integer has comma after it. And then data specification is a sequence of such objects separated by comma. So this numerical value, comma, another value, comma, another, not numerical value, but identifier followed by value. So object, comma, object, comma, object, and go out. So it is sequence of these objects like IVAR 77, vector 1, minus 3, 5, minus 20, etc. Any question about this? This is practically similar to what we did before. Now we go to study the third notation that we have, the previous notations, and this is extended BNF. Extended BNF is a notation that was introduced by Niklaus Wirth, who is the author of Pascal and many other languages. Niklaus Wirth is this guy here, who developed Pascal, Euler, Algol W, Modula, and Oberon. All these languages were developed by this guy. And he also wrote, as far as I know, the first compiler that could fit in 32 kilowords. So in machine that has 32,000 words. So that was a huge achievement to make compiler that is so compact. This is one of great programmers of all times, and he also is the author of so-called Wirth's law, which says something like this, that software is becoming slower, faster than the hardware is becoming faster, which means that programs are written in worse and worse way. Okay, so take more and more resources and become slower and slower. It is, of course, not very serious thing, but there is a little bit of joke in every joke. So it is something that he observed and mentioned that way. He wanted to get rid of a couple of things. He didn't want to have colon equal, and he said in meta language we are going to use just equality. For exclusive OR, he was using vertical line, same as in the case of BNF. However, he wanted to also eliminate recursion, recursive definitions. So to eliminate recursion, recursion is used to make sequences. So he said, if you put an object in brackets, that means 0 or 1 instance of X. You can use X or not use X. So it is optional element. So use it or not use it. So that's optional element. You can also have element that repeats 0 or any number of times. So this is written inside braces. So you can have 1 component or 0 components or 2 components or 3 components. So if you put here, for example, digit, you can have empty or a single digit or 2 digits or 3 digits or any number of digits. So this is 0 or 1, and this is 0 or many instances of X. And then you can put also grouping. If you have X or Y, for example, you can group that inside parentheses, or whatever you put inside to be a single object, you can put it inside parentheses. And then he wanted to get rid of angular brackets. So he said meta identifier is going to be written like this as a non-terminal symbol. So you can say, wait a second, how are you going to write terminal symbols? Now comes, you have to pay the bill for this luxury that you introduced here. And this bill is that you have to put all terminal symbols under double quotes in EBNF notation. Also, you're going to have multiple formulas, and each formula will be terminated with dot. So this is going to be end of definition. So if we go in this way, then we are going to have that eliminating recursion is possible by, for example, saying I have an object that can be empty or have an object followed by components. So an object is some component, any number of them. So instead of writing object equals empty or object followed by component, you can simply put braces and put component inside and say this component repeats 0 times or once or 2 times or 3 times or any number of times. So you have that object is defined as repeated component here. So if you want to summarize what Wirth did with EBNF that he used for Pascal is that there is no need for recursive definition. You can do everything without recursion. Second thing, no need for angular brackets. So you don't need to define objects of meta language by using angular brackets. You simply write the value, for example, unsigned integer, and this is the meta variable for unsigned integer. Okay. Terminal symbols, unfortunately, must be different from meta-linguistic variables. So you have to invent something to write terminal symbols. And this is double quote terminal symbol double quotes. So terminal symbols must be quoted to make them different from meta identifiers. You have to do that. So how to define identifier in EBNF? Identifier in EBNF is defined as a single letter followed by nothing or by letter or by digit. So you have that identifier is defined as a sequence where you have a single letter or letter followed by letter, or letter followed by digit, or digit followed by. So this letter or digit can repeat any number of times, including 0. So if you have that this is not having a repetition, that is none inside, then you have that the identifier is a single letter. However, if you want to repeat this once or twice, you can have letter. So this is always letter or digit. Now, you can say, compare this. Identifier is letter followed by letter or digit any number of times. And take, for example, this here. Where is it? This here identifier. Well, I guess that this EBNF is simpler of this. And it is certainly simpler than this identifier. So identifier is letter or identifier followed by character digits or letter. Or for example, here you have identifier is letter or identifier followed by letter or identifier followed by digit. So this is BNF. If you have EBNF, this becomes significantly simpler. It becomes this. Okay, come on. This one. So we have that identifier is now defined as letter followed by letter or digit that can repeat any number of times. This here is very simple, very clear, very compact, better than both BNF and syntax diagram. It is compact, it is very understandable, very short. Now you have to say what is letter. Unfortunately, each letter has to be inside double quotes, because if it is inside double quotes, then you have that this is terminal symbol. So it can be A or B or C or Z, all of them here. Digit can be 0 or 1 or 2 or up to 9. These are decimal digits. Okay. One thing that we have not mentioned, but let me mention here. If we go to one of these examples, for example, like this one here, for example, this example, we have here various objects. You have here numbers, natural numbers, and real numbers, and you have also unsigned integers. It is very critical that each of these components is labeled using mnemonic label, something that has mnemonic value. So you have to have that this is called natural number and this is unsigned integer. You cannot call this number. Yes, all of them have numbers, but number can be real or integer or natural or whatever else. So can also be decimal, can be binary, can be octal, can be hexadecimal. So you have to call these objects using names that humans understand and can use for learning the language. This notation here is used by two people. The first guy is the guy who is writing compiler. He must have or she must have this list of rules in order to build them in the syntax analyzer or compiler. On the other hand, if you want to learn the language, you again need to have this to understand what is correct syntax. And of course, syntax diagrams are rather nice, but on the other hand, you have that it is rather important to have simplicity. And simplicity and compactness is obtained here using EBNF. You have letter, and then you have sequence with letter or digit. Any question about this so far? Come on. Just unmute your microphone and ask question, no problem. Previous section had plenty of questions. You have no questions. Okay. So let us now see how Pascal defines various special symbols. So what we have here is the symbol that it has the object is called special symbol. So what is used in Pascal as special symbol? So you say special symbol equals. And this is definition of this metalinguistic variable. Special symbol equals. It can be plus or minus or times or divide. So this here are addition, subtraction, multiplication, and division. There is also possible to have special symbol written as div, D-I-V. And this is division that is defined as integer division. Pascal does not want to overload this operator. If you write slash, then this is creating a real number. So 1/2 is not going to be 0. It is going to be 0.5. And if you say 1 divide by 2, so 1 div 2 is going to create 0. So Pascal, for some reason, because it is developed for teaching programming to beginners, it should be simple. And for simplicity, you don't want to tell them about overloading. And you can say, yeah, you know, this slash works one way if you put integers, the other way if you put real numbers. And then if you put real and integer, what then? Then you have to promote integer to real, and then you have to do everything with real. So we don't want this kind of stories for somebody who shows programming, looks at programming for the first time. So practically, we want to have these two things. So this is real division. What is this? This is relational operator, equal to, less than, greater than, etc. So if you have equal to and as relational operator, the question is, how are you going to make assignment to assign a value? And well, assignment is going to be defined in this way. So colon equals is going to be assignment in your language in Pascal. So we have now assignment, and therefore we are going to use this for assigning a value. One thing that is also available in all languages is not equal to. This is written as less than, greater than. And this is frequent in many languages that you, if you don't have not as exclamation point, then you say less than, greater than, which means that this is not equal to. And this is equal to. Less than or equal to, greater than or equal to are used. This is tragically missing in C, C++, and similar languages, 2 dots. 2 dots are created for sequence of ordinal values. So you can say letters from A to F, or digits from 1 to 3. So you say 1, 3, 1 dot dot 3, that means it is 1, 2, 3, or 1, 2 dots to 50. So you have the value that is 1, 2, 3, 4, 5, up to 50. So that is a good thing. So these are special symbols, word symbols. If, then, else, for, to, down, to, repeat, until, begin, end, etc. All of them are word symbols. So by using this syntax, Pascal is a rather simple language. So what I have here is an example, just to tell you here that multiplying operator can be multiplication, division, or this div. So this is the difference between slash and div. Div is integer division, and this is real division. We'll go back here to this example. So what I'm claiming now is that you can fully understand this example if I tell you just few words. And what I want to do is a program that is computing the sum of integers. So, for example, 0 plus 1 plus 2 plus 3 plus 4 plus 10 is 55. So I want to have these 10 lines here. And I want to ask my user to enter a small positive integer, which is count this n. And if you enter 10, then you are going to have these 10 lines. So 0 plus 1 plus 2 is 3, 0, 1, 2, 3 is 4. So this is the sum of arithmetic progression. I want to display this. So how to write this program? So this is program written in Pascal. And this is now an exercise in reading program in a language that we have not studied so far. So what you can observe here, the first thing is that Pascal has here the list of variables. So Pascal program starts with keyword program. And then you have the name of this program, and you are going to have input and output. Nice. Now, this program terminates with word end and dot after that. So program ends are like left parenthesis and right parenthesis for this content that we have inside. Then, if you have right line, for example, right line like here, that means you are going to write something and put new line at the end. You have that in other languages, you have seen that. Then you have another thing that you see, that you have to define variables and their types. So variable means I'm going to use variables n, I, j, and sum. And all of them will be integer variables. So I'm declaring these variables. In FORTRAN, you don't have this. So FORTRAN compiler will have to go through your program, top down, and will go here, will say, begin, repeat, write, here is n. You have variable n. We'll put this n in stable. We'll go down here again, and sum equals 0, assign 0 to sum. Okay, so you have variable sum, put that in symbol table. Then go down, sum is sum, I is next variable. For I is 1 to n, do. You have I, so this is the third variable. Go down, you have j, that's another variable, and nothing else. So n, I, j, and sum. So FORTRAN compiler doesn't need these things. It is going through this code first time, and it is collecting variables and making symbol table. Now, in the case of Pascal, Pascal can do this translation going top down only once. So you have to say what are going to be variables you're going to use. And that's what you use also in all static typed languages, in C++, Java, or any other language that has C that has static typing. You have to say what are the objects and what is their data type. And then after that, you see another thing, that this semicolon here is not the terminator, because I don't have semicolon here after right ln. I don't have semicolon here, and I don't have semicolon here. Therefore, semicolon is separator between objects. So what we are going to do now, we are going to stop here, and I'm going to ask you that you read this program between now and Wednesday and try to understand how it works, how this program generates this table without studying Pascal. And that's where we are going to start on Wednesday. So read this tomorrow. There is nothing else to be done, no homework, nothing at this moment. And then on Wednesday, we are going to finish EBNF, and we'll also do a few examples, and we'll do parenthetic notation. And after that, if we finish everything, we will be ready for the first homework. So this is all what we have today. Thank you very much, and see you on Wednesday.